Hi, welcome to video 7, Stragglers and some DIY Plumbing. Going to talk about a couple of GPIO types that don't really fit anywhere else, and then look at how you can do some nifty things with the Node Pink GPIO pipeline. First, some important items. I'd like you to subscribe to the channel. I need all the help I can get. Click on the like button because obviously you're going to like this video. Then click on the bell notification icon to get notified of all updates. And finally, support me on Patreon if you can, please. There's a link in the description below. All donations gratefully received. Now, yesterday I told you about the latching button, but I didn't actually show you it working. I'm saving that for today. It's based on a debounced, and remember, it just kind of counts to 2. It goes 1 0 1 0 1 0 every time you press and release it. Then we're going to come across a retriggering, which is based on a raw button. It's not one of the debounced family. It just gets the absolute raw signal coming in and does some interesting things with it. And then we get the polled button, which isn't based off of any actual GPIO input. It just pretends that it is, and kind of is, but makes it look like it. It's very easy to explain. At a regular period of time, it will read the GPIO and tell you what the current value is. So when we use this latching one, it's just like a 2-position switch. Press it once, it's on. Press it another time, it's off. It kind of latches in whichever position you put it in. For the retriggering, think of a PIR sensor. The way the retriggering works is this. It's got a value associated with it called a timeout. For the sake of argument, we'll say that's 10 seconds. So what it does is that when it gets any signal whatsoever on that pin, the raw signal, so it doesn't matter if it starts being bouncy, the very instant it changes to a 1, the retriggering GPIO fires a 1, and then 10 seconds later it will fire a 0. Whatever else happens on that pin, the state that it's gone back to, rather, because if it goes back to 0 at 5 seconds, the retriggering's still going to wait for 10. That's what that timeout period means. I'm not going to give you a message until at least 10 seconds after the last triggering event, brackets or retriggering event, because if that goes off at 5 seconds and comes back on at 7, it will re-trigger itself and it will start the timer again. So you won't actually get the signal until 17 seconds after the first one. So just like a real PIR timer, if something keeps moving in the field of vision, the signal stays at 1 to show you that there is still something there, and only 10 seconds after the last event do you then get the all clear to say that it's off. Now, the polled is very useful for checking values that change very, very slowly and tend to flicker between 2 values when they change, such as a daylight sensor. So as the evening wears on, you want to put your safety alarms on and everything. If you're checking the state of the light sensor 10 times a second, that's just going to go flip-flop, and what we call hammer. So you need to add a lot of what's known as hysteresis, kind of delay in the readings. And really, on the systems that I use, I have a 5-minute poll time. And even that's a bit quick sometimes on a long, late summer evening. But for things which change very slowly, that's very handy. It's also very similar to the way that all the analog readings work. There's 6 or 7, I can't remember which, different analog methods that we use to help you, and so there's enough of those to make their own video. They will be covered next time round. So those are the stragglers. Apart from the analogs and the encoders. That's all the kind of individual buttons, GPIOs. And what these have in common is that they all send a GPIO event out of the far end of the pipeline. And all the code you've seen so far has had that event handler which picks up that GPIO message and then does something with it. Okay, well, now that we've got Super Mario the Cyber Plumber, he's got a few little gadgets in his store cupboard that you might like to play with. So the first thing you might like to play with is one of those. So instead of sending a GPIO event, it calls a function which updates an integer. So you can have an integer called myValue, and by putting that at the end of the pipeline, whatever comes out of the pipeline gets automatically put into that integer myValue. You can check it whenever you want to check it, and it will have whatever the last value was in there, just already in there for you. Another gadget you can put on the end of the pipeline is an update global, which does a very similar thing to the int, but it does it to a global variable. Now, if you read the section of the documentation on global variables, you'll know that whenever you change the value, they send an event, and the event they send is a GV change. So you don't get a GPIO event out of it, but if you put one of these on the end, you'll get a GV change with the name of the variable that just got a new value poked into it, and that can be very useful sometimes. For example, it's the final thing in Uncle Mario's box of goodies, is a thing called publish on off. Now, in order to know what that is, you need to understand a little bit about switches and things, which again you can read the documentation. I'm going to do a video in the future about them, but essentially what that does is change the value of a global variable called state. Now that normally represents the default state of a device for being switched on and off. The thing that does the switching on and off is called a binary switch or a binary thing. And what this does then is take the output from the pipeline and automatically tell the device to do what the default on-off action is, if that makes any sense. And if it doesn't, it will do in a moment, because we're going to go live to the lab and I'm going to show you the publish on-off happening. Now, one point to note just before we do that is that these replace the final stage in the pipeline. They don't stick onto the end of it. You don't get a GPIO event and then one of these. You get this instead of a GPIO event. So bear in mind that if anybody else is listening for that GPIO event, you're going to stop them hearing it. So be careful. Welcome to the lab. Here's a piece of code that line, it shouldn't be in there. I'll tell you about it in a second. It's from the previous version of this that I did when I screwed it up, so I have to do it all again. So, hey, we're all human. But anyway, look, here we go. We've got a thing called a binary switch, and we've got the latching in action. And that's all the code we've got. So apart from the 2 mandatory lines which you have to have in every sketch anyway, there's 2 lines of code here. And what they do is this. So the binary switch recognizes a state change, and when a state changes, it changes the state of D6 to match the state. And that's the red LED. So, well, that's not that clever, is it really? Do you know what? Is it? The thing is, if you look at one of the very first videos we looked at, called a Blinky on steroids, you'll see that there's all H4 plugin sketches can be commanded and controlled to do what they need to do from a variety of sources. So if I type H4 on into the serial command window, our red LED goes on. If I type in H4 off, I'm really good at this typing thing, aren't I? It goes off. All right. The beauty is that the same thing will happen if I use my latching switch to send it to 10, because all that was happening when I typed in those serial commands is that they changed the global variable state to either a 1 or a 0. So if I press the latching button all nicely debounced. It doesn't flicker the thing on and off. That just sends a 1 to the binary switch. The binary switch says, oh, I'm linked to D6. Let's send the 1 to D6. So with those 2 lines, you get a complete self-contained debounced switching on and off thing that if you go back and do the bit that I shouldn't have had in there at the beginning and put a Wi-Fi plug-in at the beginning of it, A for Wi-Fi, Y-Fly, and then put in your username, SSID rather, and password. Recompile that, you'll be able to turn that LED on and off not only with the button but with the any other device in your system that can send an HTTP request, and that would just send an HTTP request, your IP address, rest H4 on, and your lamp goes on. You can do the same with MQTT if you add the MQTT plugin in, and there's a variety of benefits that you get. When you load up the Wi-Fi, you'll get a web server that shows you the state and, if you choose carefully, the colour of the LED that's going on and off, and it will show you in real time what the state of the device is. So let's take that little line out there because that's not the code that's running, that's a bit of a cheat. So that's what's running in there, 2 lines including all of that, which I think you'll find is quite useful for doing things quickly. But the one trick there is that at the end of it you can see there's this, a new NP publish on off thing. NP is for Node Pink, publish on off you kind of know by now, and this new just creates a new instance of one of these things, and that will overwrite the GPIO on the end of the pipeline of the latch, so that when the latch fires, what used to be there has gone, but instead the publish on off sends the value to the state variable, which then the binary switch then reacts to. So no function this time to do all of the event handling. You don't need to do that. These things talk to each other behind the scenes. All of that happens automatically just by having those 2 things in there. So one final thing, just to link some stuff together, I've just remembered, is that at the end of the GPIO, where we talked about the timer things, and we had the multifunction button, and the multifunction button by default on a short press sets the switch on and off. Well, here's how it does it. If you need a binary switch really to show it working properly, but the multifunction button effectively does that at the end instead of sending the GPIO event. That's why when I showed you that code, I had to do a little bit of cheating and set the LED myself, and I said normally you wouldn't have to do that. Here's why: because if this was a multifunction button, you wouldn't need to say that because it does it anyway, but it does what it does by changing the state variable. And if you put that in the same sketch as a binary switch, then you get 3-way control for reboot, factory reset and short stab on off. Now I hope you're starting to see that by carefully combining plugins you can get a lot of power with very, very little code, and that's the whole point of it. And it all runs independently of each other so that nothing interferes and you can't crash, and it's all asynchronous. So everybody's happy. Except me, who now has to add some YouTube cards to the end of this video, because apparently that's the thing to do these days. I'm all a bit new to this. So just bear with me, because I think I have to kind of stay quiet for about half a minute at the end of the video to give me space to put these cards in. So if you see nothing more, it didn't work and I don't know what I'm doing. If you see some cards, click on one of them and watch one of the other wonderfully exciting H4 plugins videos. Thanks for watching this one, and I look forward to making another one for you very soon.